Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'll tell it how I title in the title. But what I am sure of are 3 goals for the day. And our first goal is going to be to solve one-step inequalities using addition or subtraction. Our second goal is going to be to graph the solution. And our third goal is going to be to check. So the good thing is we already know how to do the first goal because we're going to solve using addition or subtraction. We just used step 5 from our 6 steps to solve. The graphing was what the first lesson was about in this chapter. And then the checking, that's a little bit new, but I think that's something that we can understand. But again, all we need to know is step 5 from the 6 steps to solve, and I wrote it down right here. Step 5 says add or subtract away a number from the variable side of the equal sign, and you do that if you have a plus or minus between the number and the variable, and I didn't close the parentheses. Okay? But I need to edit this just a little bit because we are not solving equations. We are solving inequalities. So this should read add or subtract away a number from the variable side of the inequality symbol. It's the same idea, and that's what's nice about this section is we're doing things that we already know how to do. We're just adding a little bit more. So after we solve, isolate the variable, we go into the graphing, and again we think of left of and right of, and the variable is the shading, and I'll talk about how we check. I have 2 specific examples that I would like to do. Let me change this last one just a little bit. Let's make that a -3. Okay, there we go. Alright, so I'm going to solve this, graph this, and check it, and I'll be hitting all 3 goals. So first, I need to find a number that's on the variable side of the inequality, and that is +8. So to make +8 go away, I need to subtract it to both sides. -8, -8, and it's very much what I do to solve an equation. So now I get the x that comes down, I did nothing to it. +8 minus 8 is 0, so it actually cancels itself out. And that is greater than or right of 10 take away 8 is 2. So I've solved this, I've isolated the variable. So one step by solving by adding or subtracting. Not too difficult on that. So the next thing I need to do is I need to go into the graph. But before I graph, I'm going to translate it. So remember the variable is the shading, and so this would translate to the shading is right of 2. The shading is right of 2. Now you don't have to write this out, but I'm writing it out just to reinforce the idea that we can take this as a direction to describe the graph. So the shading is right of 2. So I have my number line that I'm going to draw. This is an open. This means I have an open circle at 2, right? Right of open circle. All right, and the shading is right of 2. So that's an email. So that is what the graph is going to look like for this inequality. And I want to add something that I didn't add. The solution is the graph. It's very important that we understand that the solution is the graph. The solution is the shading on the graph. And so what that means is any number in the shading is a solution. So the solution is the shading on the graph. So if I pick any number in the shading and I plug it into my inequality, I should get a true statement. So I like the number 4. I will plug in the number 4 because 4 is in the shading. And so let's plug this in and see what we get. So I'm going to write my inequality, but everywhere I have an x, it's going to now turn into 4. So I have 4 plus 8. Is that greater or right of 10? And again, I can just pick any number in the shading, and I will hopefully have a number that will make a true statement. So 4 and 8, that gets me to 12. 12 is greater than or right of 10. So let's interpret this. Okay, let's look at a number line here. I got my 0. I got my 10, and I got my 12. Is this a true statement? Is 12 right of 10? Yes, 12 is right of 10. This is true. So this is how we check. We pick a number from the shading, plug it in, and make sure we get a true statement. Okay, so that's what that one would look like. I have another example. It would be the best idea if you hit pause and try to solve this one on your own. I hope you hit pause and try and solve it on your own, and hopefully you did. And now you're back to see how you did solving this thing. Alrighty, so again, it's a one-step problem. We're going to solve by adding or subtracting away a number from the variable side of the inequality symbol. And I know that I can do that when I have a plus or minus between the number and the variable. Well, I have a minus 3 on the variable side of the inequality. It's separated by a plus sign, so this is a number I need to make go away. I make it go away by adding 3 to both sides. Plus 3, plus 3. That cancels out and becomes 0. I owe you $4, I give you $3, you tell me I owe you $1. That is greater than or equal to, or on the right side or at, the shading. So -1 is right of or at the shading. So now, actually, before I continue, I want to make sure I'm still on the screen, because I really don't like having to redo these. I have plenty of room, so I can actually pull this off to the side. So this is one way to describe the inequality that we have. If I start off describing with a -1, it's right of the shading. If I do another description of this, I can say the shading is left of or at -1. Alright, and I like starting off with the shading when I talk about graphing, because it's easier for me to understand what side of the number it's on. But I'll show you that, in fact, either description is going to match the graph that we're going to create. So I have this symbol, which means that I have a closed circle. So let's shade that in here. Shade that in here. And the shading is left of that closed circle. But I could also say that -1 is on the right side of the shading. So both of these statements do describe this. So I've solved it, I've graphed it. Remember, the solution is the shading on the graph. Now, the boundary is shaded here. It was not shaded there. It is a solution here, but don't check with that. Always check with a number further along in the shading. So I think I will talk about, let's say, I like the number -4. -4. Okay, -4 is in the shading. And so let me plug this into the original. -4 greater than or equal to -3 plus a -4. -3 plus a -4 is a -7. All the crickets are back. And is this a true statement? Is -4 on the right of -7? Well, let's make our, oh, they're back with a vengeance. Okay, so my -4 is in fact on the right of -7, and this is in fact true. So this is what I'm looking for in the first lesson of solving linear inequalities with one variable. And again, we get to use something that we already knew. So hopefully this makes sense on how to do this. I'm going to go ahead and end it here. I think the crickets are done hearing me talk to myself while I teach math. Again, I hope everyone's having a good day out there. Have a good day, everybody. Bye-bye. That was a terrible clip.